let's talk about special right triangles. So a right triangle is a triangle that contains a 90-degree angle in it. And special right triangles are a specific type of right triangle where we know all of the ratio of its side lengths depending on its angles. So an example of a special right triangle is the 45-45-90 triangle. And as the name states, the angle measures of this triangle are 90 degrees, 45 degrees, and 45 degrees. And as you can see, this is actually an isosceles right triangle because 45 degrees is repeated twice, and these angles are equal. So the side length ratios of this triangle are 1, 1, and square root 2. And this is always true if these angles are given. So let's look at another special right triangle. Another special right triangle is the 30-60-90 triangle. That's a little different because it's not an isosceles triangle. So if we draw this out, it will look like something like this. And let's say this is 60 degrees and this is 30 degrees. The side length measures for this one will be 1, square root 3, and 2. With the 1 being opposite to 30 degrees and the 60 degrees being opposite to root 3. So let's do a couple of example problems. So let's say we're given a right triangle with 1 degree measure of 45 degrees. And we're given the hypotenuse as 4 square root 2. How would we find the area of this triangle? So in order to find the area, what would we have to do? We have to find the height and the base. So since we know our side length ratios, because this is a 45-45-90 triangle, because this angle is 45 degrees, that means we can apply our ratio. And we know the ratio is 1, 1, square root 2. And if this is 4 square root 2, that means both of these sides have to be 4. So then we know the area is equal to base times height divided by 2, which is equal to 4 times 4 divided by 2, which is equal to 8. So that is our answer. Now let's do one more example problem. So if we look at a 30-60-90 triangle this time, let's say we're given another triangle. Let's say this one's 60 degrees. And they give us this side length as 2 square root 3. How would we find the perimeter of this figure? So in order to find the perimeter, we actually need to find all of the side lengths and add them up. So since we know this is a 30-60-90 triangle again, because the angles have to add up to 180, we know the ratio between these side lengths. So the ratio is 1, square root 3, and 2. And since this is 2 square root 3, that means this has to be 2, and then the hypotenuse has to be 2 times whatever this is. Since this is 2, then this has to be 4. So our perimeter would simply be 2 plus 4 plus 2 square root 3, which is equal to 6 plus 2 square root 3. Now special right triangles can get a little complicated, so I've attached a practice worksheet and its answers in the comments below, so make sure to check that out. Thank you.